So now let's talk about limits that don't exist. But before we do that, let's do a quick recap. Okay, so a limit, we can the notation that we can use is as such, like this, right? Okay, so for this limit to exist, the left-hand limit must equal the right-hand limit. Right, and if these two limits are equal to each other, and they equal L, then that's what the limit equals. Okay, and if the left-hand limit and the right-hand limit are not equal to each other, so if the left-hand limit, if the left-hand limit is not equal to the right-hand limit, like this, then the limit does not exist. E and E does not exist. So if the left-hand limit and the right-hand limit do not exist, if the left-hand limit and the right-hand limit are not equal to each other, then limit of f of x as x approaches c does not exist. Okay. So let's do example. Oh yeah, it's very important to not assume that the left-hand limit has to equal to the right-hand limit. Okay. Always check it. So let's do that for this example. Okay, so we have a split function here which states that if x is greater than 10 and f of x is equal to 3, and if x is smaller than or equal to 10, f of x is equal to x minus 4. You can draw a graph if you want. Right, so we get a line, right, x minus 4, if x is smaller than 10, smaller than or equal to, and if x is greater than 10, f of x is equal to 3, so we can clearly see that, the question is the limit of f of x as x approaches 10. You can see that left-hand limit and the right-hand limit do not equal each other. See, they don't meet, and therefore this limit does not exist. If we want to write it out, we would do this. Right, so limit of f of x as x approaches 10 to the left is equal to 6. The limit of f of x as x approaches 10 from the right, positive sign, is equal to 3. These two numbers are not equal to each other, and therefore the limit does not exist. Notice that the limit only does not exist for this function at x equals 10. So if we were to pick another point, so if I were to ask limit of f of x as x approaches 1, it's perfectly fine. The left-hand limit is equal to the right-hand limit, and they're both equal to -3. Okay? So we can see here that a limit cannot exist if the left-hand limit does not equal the right-hand limit. Okay, and let's try another example. Let's try the example, limit of 1 over x to the 4th as x approaches 0. We draw a graph here, we get this. And you can see that as we come in from the left or from the right, we go to infinity and beyond. Right, so it blows up. It blows up. The function blows up as we get closer to 0. So what do we write? The limit has to be a real number, and infinity is not a real number, therefore the limit does not exist. So the limit does not exist. However, D&E, we can write it as this way, though. Wow, it's a really bad infinity sign. Right, let me write that. There you go. Somewhat better. Right, so, sorry about that blurb. There you go. So, the limit of 1 over x to the fourth as x approaches 0, we can write it as an equal sign and an infinity sign. However, we have to keep in mind that this equal sign means it tells us why limit does not. It tells us why the limit does not exist. Okay, this equal sign does not mean an equal sign. This equal sign in this case tells us why this infinity does not exist. Okay, it's a mathematical pickiness or concept, but the textbook mentions it, so therefore we mention it. So in actuality, this limit does not exist, but we can write it this way. We can write equal equal infinity sign, as long as we keep in mind that this equal sign tells us why this limit does not exist. Okay, so we can write it as this. That's perfectly okay. That's an accepted convention. Okay, and one more. And let's do the limit of cosine 1 over x as x approaches 0. Doesn't look too harmful, but you know what? Let's do a table. Okay, let's start from the left side and from the right side. So let's, you know what? 1, 2, 3, 4. Let's start from the left side. Now we'll take the note. Notice that Notice that this function is undefined at x equals 0 because cosine of 1 over 0 is undefined, and therefore cosine of something that's undefined is obviously undefined. So UNDF, undefined. So let's start with the right side. Okay, so let's work our way in. You know what? Let me think how we should do this. Okay. Right, so notice that as we move, as we move in closer to 0 from the left side, you know what? Back up. Let's evaluate these first. So cosine of 1 over 1 over pi equals cosine of pi, which is equal to what? -1. Good job. Cosine of 1 over 2 pi is equal to 1. Cosine of 1 over 3 pi is equal to cosine of 3 pi, which is equal to cosine of pi, which is equal to -1. Hopefully you followed that. It's oscillating. Let's do the same thing but with the other side. Okay, so hopefully you can read this. Okay, it's kind of small. This reads -1 over 3 pi. So cosine of 1 over -3 pi is equal to cosine of -3 pi. Right? So cosine of -3 pi is going to equal what? It's going to equal -1. Sorry. Cosine of 1 over 2 pi over -2 pi is going to equal to cosine of -2 pi, which is going to equal to cosine of 0, which is going to equal 1, and cosine of 1 over -pi is equal to -1. Whew. It's oscillating. It's -1, 1, -1, -1, 1, -1. You can't have this. In the previous examples, we saw that. That looks nice here. Let me get this here. Remember, this is the table that we had in the first lesson. This one here, the equation was this, right? So here, as we move in closer to 3, this thing was increasing to 10 from left, and here it was decreasing. It's increasing and decreasing. It could be all the way around, but it's always here. It's always increasing. Here, it's always decreasing. Here, it's decreasing. It's increasing and then decreasing and then who knows what. It's oscillating. And for the limit to exist, these numbers must be approaching the same number as x gets closer to 0, and they're not, right? F of x must settle down as x gets closer to 0, and in this case, they're not. Therefore, this does not exist. And here's a function. Here's a graph of that function. As you can see, it's going in and then it's going up and down, and coming out like that. Okay, so as we get close to 0, it's going up and down so fast. If we continue this, we could see that it's going to go 1, negative 1, negative 1, 1, negative 1, 1, negative 1. See, it goes down to negative 1, and then goes up to 1, like so. Okay, so it's oscillating behavior, and therefore does not exist. So we covered 3 examples, 3 cases in which the limit does not exist. This happens when the left-hand limit is not equal to the right-hand limit, and also when it blows up, when the limit blows up, and also when the function blows up as x approaches c, and when the limit is oscillating back and forth. Sorry, I was looking at the computer's a bit weird. That's why I hesitated there. In the next lesson, we'll do a pretty cool graph thing. See you there.